All right, welcome. In this lesson, we will practice factoring and finding all of the zeros or roots for polynomials. And we're going up to degree 4 and higher, so not just cubics. So pretty much using the skills that we're going to practice, we should be able to factor almost anything. Okay, for this assignment, we are told that using our TI-30XS multiview is okay. So let's do that. Let's type this equation into the table feature of our calculator. All right, so it looks like we have x to the 4th power, okay, plus 2x to the 3rd power, plus x squared plus 8x minus 12. All right, I like to start at -10 because it rarely goes past that. And then I'm scrolling down looking for zeros on the y side. Wait for it. Kabam! First one is -3. So let's rock that. So I've got -3. Okay, and so right there I've got -3 is my first zero, which gives me a factor of x plus 3 by the way. Okay, synthetically I have 1, 2, 1, 8, -12. Okay, I bring down that 1 and such. So that's going to be -3, -1, +3, 4, -12, -4, +12, 0. Now, see the pattern 1, 1, 4, 4. See how it's like doubles? That just screams grouping to me. So I would definitely try to group right now if I were you. So if you put the variables back in, this is the constant, so this is the x term, so this is the x squared term, so this would be x to the 3rd. So I've got x to the 3rd power minus x squared plus 4x minus 4. Now I would love to group this, my friends, group it. So if I look at these two and I look at these two, the GCF between the first two terms is x squared. So I could pull out an x squared like that. Okay, then at that point, that's going to leave behind x minus 1. Now, looking at the next pair, 4 is the GCF. So I will pull out plus 4. And that's going to, again, leave behind x minus 1. See how it's the same thing twice? That's going to be crucial to our grouping. So I could take this x minus 1 and factor that out. Put it out front. So I'll have x minus 1, and that's going to leave behind the pink part, x squared plus 4. Okay, that's going to leave behind this x squared plus 4. Now, please let us not forget the factor that we get from the 0 of -3 that we got from the calculator. We need to bring that down. So this gives us a factor of x plus 3. Now, we always would look at this quadratic factor and see if we can factor it more. Can this factor more? No. If this were x squared minus 4, then we do x plus 2 times x minus 2, because that would be the difference of two squares. Here the subtraction when I say difference, but when it is the sum of two squares, that is unfactorable. So there we have factored completely, and now we can get our zeros. So we already had the -3 straight off the calculator, and from the setting x minus 1 equals to 0, that's going to give us x equals 1. Okay, and now by setting x squared plus 4 equal to 0. All right, if I subtract 4 from both sides, that's going to give me x squared equals negative 4. Okay, so then I would take the square root of both sides. Don't forget your plus or minus, guys. So that's going to give me x equals plus or minus 2i. All right, square root of 4 is 2. If I have a negative under the radical, that's going to be I. So plus or minus 2i. Okay, so, and I like to split it up as 2i and negative 2i. Remember, the fundamental theorem of algebra, if the degree is 4, then we should have 4 zeros if you count repeated zeros. And there we have our 4 zeros. Okay, so that is it for problem number 1. Let's go ahead and do problem number 2. Now, instead of giving you this as a function, I've given it to you as an equation. When I do that, just get 0 on one side. So we will just add 10 on both sides and proceed as normal. Okay, so this is going to give us x to the third power minus 3x squared plus 6x plus 10 equals 0. So let's go ahead and type this into our calculator and see what zeros we can find. All right, so here I've typed it into my calculator. I'm using the table feature. So I like to start from negative 10 because it rarely goes past that. And then I just scroll down from there. Okay, so I find a 0 at negative 1. So let's use that. So if I do my negative 1, which by the way, I might as well put that root. And here I'm using the word roots, okay? And before I use the word zeros, technically you find the zeros of a function, you know, f of x, but you find the roots of an equation like this. So see how there's no f of x? So if you want to be technical, if you have an equation, we're going to call them roots. But if you have a function, you know, with the f of x or even a y equals, then we call them zeros. But it's basically the same thing, but I thought I'd raise your level of education right then. Okay, so we've got 1, negative 3, 6, and 10. All right, so if I bring this down, multiply, I get negative 1, add, I get negative 4. Multiply, add, multiply, add. Okay, so now I have this trinomial, so this should be factorable. Okay, so if I put the variables back in here, I've got x squared minus 4x plus 10. Okay, I wonder if this is factorable. Probably. Also, do not forget the factor that you're going to get from this negative 1. That's going to be x plus 1. Okay, now as I try to factor this, let me just switch colors for a second. As I try to factor this, I look at x squared and I'm thinking x times x. I look at 10, I'm thinking 2 times 5. That's not going to work, all right? Inner plus outer has to equal middle. And so I'll have 2x and 5x. There's no way I'm going to get 4 out of that. It'll be even worse if I try to do 1 and 10, all right? So this is actually not factorable. It's not factorable, okay? So to find the zeros, the roots of the equation, I'm going to have to do something else. So first of all, as far as the factors go, I'm done. This is officially completely factored. Now, if I want to find my other 2 roots, all right, because you know there should be 3, all right, look at the degree. If I want to find the other two, I need to set this equal to 0 and solve. And I'm going to show you two ways to solve this right now. Let's see. Let's go to the black screen. There are two ways I can show you this. Method 1 is the quadratic formula. Okay? The quadratic formula is this. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And there's a little song that helps you remember. Opposite of b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. So I know you're laughing right now, but that will help you remember the quadratic formula. Okay, play that back again as often as you like. Now, a, b, and c are the coefficients of this polynomial. So, in this case, a is 1. Okay, so we have a is 1, b is -4, and c is 10. Okay, a, b, and c. Now, I recommend not putting all of this into the calculator at once. Okay, I always like to do the b squared minus 4ac part separately, and I recommend that you do the same. Okay, so look at this b squared minus 4ac part. Look at it. Okay, so I'm going to do that first. So b squared minus 4ac. Okay, that's -4 squared minus 4 times 1 times 10. Okay, and some of you guys need to put this in your calculator, but make sure you put the b squared, the -4 in parentheses. So -4 squared minus 4 times 1 times 10. That's what it was, right? Yeah. Okay, so kabam, that's -24. So make sure you get that. Okay, so that's the part underneath the radical. So if I go ahead and do the rest of the quadratic formula, so x is equal to opposite of b. b is -4, so the opposite of b is +4. All right, and then I've got plus or minus square root all over 2a. Well, a is 1, so 2 times a is just 2 times 1, which is just 2. And then underneath the radical here goes your b squared minus 4ac. Well, that's -24. Okay, as soon as you see that negative under the radical, you know we're going to have imaginary solutions. So watch out for that and be careful. Okay, the way I handle that is you've got x equals 4 plus or minus. As soon as I see that there's a negative under the radical, I'm going to put that in the front as I. Okay, so I've got I. Okay, that negative becomes this I right here. And for now, I've still got my square root, still got my 2, and I've still got my 24. Okay, now that that negative's out of here, go ahead and take the square root of 24, okay, in your calculator. So, all right, square root of 24, that's 2 radical 6. Okay, so now what I have is, and just put a little line right here. Okay, so I've got 2 radical 6. Now remember the I should leave space for it. So I've got my 2 radical 6, but this I just goes in the middle like that. Now we can simplify this. Watch what I'm about to do, you guys. see how these three numbers have a GCF? All three of these numbers are divisible by 2. What I like to do is I like to draw a heart around those. Okay, isn't that lovely? Doesn't that make you feel nice? Okay, it's not even Valentine's Day. It's not even February. But I'm rocking it anyway. Because I love to do this. If these three numbers are all divisible by 2, let's go ahead and do that. Let's divide all three. It has to be all three. That's part of why I'm drawing the heart. You can't just do 2 of them. You have to draw the heart and do all three. If I divide all three of these numbers by 2, then I'm going to get, okay, x equals, all right, 4 divided by 2, so that's 2, plus or minus, and 2 divided by 2 is 1, okay, but I don't need to put the 1. And I still have my square root of 6. Now this denominator, again, 2 divided by 2 is 1, okay, but I don't need to put the 1 when it's on the bottom. And don't forget your I, okay. It's hard to see when you don't have an I. Okay, so this is what I will have, 2 plus or minus I radical 6. And this is your final answer from this particular problem. Okay, so let's get that back to the paper. So setting this thing equal to 0 and solving, we got 2 plus or minus I radical 6. And that's going to give us 2 plus I radical 6 and 2 minus I radical 6. Okay? Now, I said there were 2 methods of doing this, and that was just the first method. That's your quadratic formula. The other method of doing this is completing the square. So I would like to show you that as well, but I feel like I need to get to another page or something. Okay, need more space. Okay, so let's do the same problem by completing the square. All right, method 2 is called completing the square. So here is how we solve an equation like this by completing the square. Well, first of all, this third number usually has to go. So I'm going to take that third number and move it to the other side of the equation by subtracting 10 from both sides. Okay, so that's going to give me x squared minus 4x. Now this, we've moved the 10 now, just leave that space empty. And that's equal to negative 10. Now, this number that we're going to put a new number in the empty space here. We get that by looking at the middle. We're going to take half of the middle and then square that. So half of 4 is 2. Okay, so we take half of 4, we get 2. And then we take 2 and we square it, and we get 4. Okay, so I'm going to put a plus 4. Now, I just added a 4 on the left that wasn't there before. It's messing up my equation. I have to balance it out by also adding 4 on the right. Okay, anything you have to do it on the left and the right to keep the balance. Now you might be thinking, oh, if this is a 4, is this going to be a 4 every time? No, that's just a coincidence. You have to do half of the middle and then square that. Okay, so let's go from there. Now, by picking this special number, we are guaranteeing that this will factor as the same thing twice. So this is going to factor as x minus 2 times x minus 2. All right, add these up, you get negative 6, by the way. Okay, the good thing about having it be the same thing twice is we can write this as a package deal. X minus 2 squared is equal to negative 6. Now I can easily solve this by taking the square root of both sides, like this. Do not forget your plus or minus on that. Okay, and that is going to give me x minus 2 is equal to plus or minus radical 6. Now, what about that negative? You know what I'm going to do with that. When you have a negative under the radical, it's going to come out as an I. Okay, that negative became the I. Okay, and last step I need to get this x by itself, so I need to get rid of this 2. So I'm going to add 2 to both sides, okay, but I'm going to put it in the front. Okay, so I'm going to end up with x equals 2 plus or minus I radical 6. All right, and you'll recognize that this is the same thing we got by the quadratic formula, but I actually think that this was a little easier to do, a little quicker than the quadratic formula was in this case. Okay? So, but you be the judge. Some people love the quadratic formula, but if you learn completing the square, it's called completing the square, you might find this to be even easier than the quadratic formula. Okay, this is a long video for only having done 2 problems, so I'm going to stop this video right here, and I'll see you on the next video.